My guest today is Mihai Tataran. Mihai, how are you, my friend?
Good. Nice to see you, David. It's been a long time, a few
It's been a
months,
long time. Last time was in Chicago almost a year ago.
almost a
In the
year
night.
ago. It's two continents and an ocean between us,
I
but
know exactly. There you are in Romania. I can't remember. You're in Timișoara. Is that right?
yeah, love the
Okay.
t-shirt, by the way.
I was there. I've been to Romania many times at your invitation. I'll start by saying this. I've always been grateful for the fact that you gave me my first international speaking opportunity. Since that time, that was what 12 years ago, I think, and
Yeah,
we met first in Boston, and then again at the was it Tech Ed conference, I think,
yeah.
and and you invited me to speak in Romania. And since that time, it opened a lot of doors for me. I've spoken all over the world since then. So thank you for that opportunity.
No, the
You
pleasure is
kicked off some
mutual.
amazing stuff.
Appreciate it.
And
The pleasure is mutual.
yeah, and it's I love visiting Transylvania. I need to get back there.
Yeah, we have to arrange that somehow.
And let's talk about what you're doing now. What you still have your company?
Yeah,
What kind of things are you focused on these days?
that's a great question because since a year and a half ago, approximately, I have a co-owner, which is a private equity. Um, so I still own part of it. I still manage it day to day. I'm still the CEO. And since last year in spring, approximately, we've been doing more work with AI, more focused on generative AI, which is awesome, which we love, by the way. And not just for the sake of technology, but also for its actual output, right? What it can actually do. And our traditional customer is usually a large or mid-sized to large enterprise. Those are our customers, as opposed to small companies or extremely large enterprises. And we already see benefits there since at least a few months ago. It already makes sense economically and financially for them to invest, and that's great. And now we're talking about larger projects with larger impact. So it's awesome. I travel a lot to the US these days. I've been three times since then, right? To Microsoft or to Microsoft conferences, just to keep up, because what Microsoft is doing, it's very good, and it's always nice to meet with friends in this space, but especially nowadays at these conferences, you see a lot of very rapid evolution of the AI technology stack.
Awesome. Let's talk. Well, you mentioned generative AI. Can you quickly define what that means?
Well, I'm not the perfect guy to do that. I'm an AI engineer or like a guy which implements that. I'm not a researcher, so just to have a disclaimer out there. But it's basically the artificial intelligence which generates content. We usually associate it with generating text, and with typical applications of that being, pure text or code. That's a specific type of text that we are actually very helpful, very very happy to be helped with. It also refers to images or to videos or to audio, in general, generating things. And the original purpose of, or the original way, the models, the foundation models, the large language models that were built, or the original purpose was to generate text, which might not be perfect, which might not be accurate, because it could be used to generate, for example, a marketing campaign or a copyright or things like that, right? So the original, I would say, purpose, or the way it was thought it will be used originally, comes from that kind of thought process, right? So it's highly non-deterministic, of course, and it's also inaccurate. It's not supposed to be accurate, right? And that's why sometimes us people who apply it, or our customers, have a very strange relationship with generative AI, right? Because we expect AI to be very deterministic and very accurate and very precise, which is not the case, especially with generative AI. Now, in the last months or last year, I would say, The Gen AI world, the large language models world, is clearly split into or divided into LLMs which generate text. We call them completion models, and the ones which we call rationalize, or how do you call them? It slips my mind right now. The ones which are supposed to actually resolve a problem, right? We
Hmm.
call them. It's gonna come in a minute to me, but anyway, do we have these models which are reasoning models? Oh my god,
Okay.
right? Reasoning models. Like O1 was the first one to come out and to have a public appearance, which is more very public. And with reasoning models, we are getting close to what the customer, what the user expects in certain problems. I mean, when I ask a question which should have a definite answer, I should definitely ask that question to a reasoning model, right?
Okay.
But without getting into the rabbit hole yet into this conversation, because of the inherent purpose and the way those LLMs, talking about specifically text, right? Text Gen AI were built, they don't actually work as one might expect. That has a few outcomes, right? Some of them unpleasant, like, for example, people start not to trust Gen AI because
Right.
they think it's stupid because it doesn't answer correctly. And how do you gain the trust back from those users? Well, two ways to do it. One, of course, teaching and explaining what they do and what they don't do, and then evaluation, testing and evaluation, techniques, methods, technologies, everything around that, so you can show them how accurate or how wrong they actually are. And there are many, many scenarios where you can actually, business wise, right, you can accept an AI which is not 100% accurate.
Okay.
uh, in a certain business process, the human might be 50 or 60% accurate, while the AI that you can build today is 70 to 80% accurate, which is a very big improvement.
Right.
As long as you have the explainability and the exceptions, which are outcomes of the evaluation, by the way,
Okay.
you can get away with that very, very, very well.
So setting the expectations of the end user that yes, this is better than not using it, but it's
Yep,
not perfect. You need to trust but verify. It's don't just take it as gospel that it's everything out there is 100% accurate.
exactly.
And you mentioned testing this. This is when I think about testing, I think about automated testing, like unit tests, for example.
Mhm.
And I'll create a test that says, okay, given these inputs, I expect this output, validate that this output occurs every time I do these inputs. But that's not really possible with something that's non deterministic like generative AI because I don't know. There isn't an expected output. I might run it 10 times to get 10 different outputs. How can we test that?
Yeah, so you're completely right, and to give you a much longer answer than you're actually asking me, this is one of the core elements that us in the industry and our customers need to change as a paradigm. Testing and evaluating Gen AI solutions is very different than software testing, right? As you
Mm.
mentioned, unit tests, automated tests, they are deterministic, right? You have some inputs, you expect some outputs. That's a black box testing, right? Here it's very different, right? Meaning, as you said, it's non-deterministic. The way you test it, there are certain methodologies, certain frameworks that you start with, certain technologies in the end. We're going to mention them throughout this discussion. But in the end is trying different data sets as input and comparing the outputs with what you would expect. And of course, it's not a one or zero, it's a probabilistic, or it's
Okay.
it's a number between 0 and 1, or it's a number between 1 and 5, depending on the specific method to test specific performance indicators, KPIs, right? Because there, I'll give you some very, very brief examples, right? For Gen AI solutions, we're talking about specific KPIs like coherence, like fluency, like relevance, right? We're talking about reliability. We're talking about safety. So just to give an example, a reliability or a safety, right, API will measure how many of, and that's a 0 to 1 number basically, right? What's the percentage of the completions that are unsafe or the
Mhm.
answers to an unsafe prompt? Unsafe being either harmful, with violent contents and so on and so forth. It could be even more towards security, like actually asking for data which should not be exposed. And those KPIs like safety are evaluated on a very certain scale, right? And you define what's good enough for you on that scale based on a framework, based on a governance framework. And a very good starting point for defining your own thresholds would be using NIST, so National Institute of Technology in the US. They have a thing which is called AI Risk Management Framework.
Okay.
And based on that, that defines very well how you deal with risks in AI. How do you identify them, how you manage them, and so on and so forth. There are like 4 steps to do that. But it's also a very good starting point to have your thresholds established, right? I mean, for example, you might say in certain business scenarios, you want safety to be, or let's say, responses to violent or sexual or whatever inappropriate content to be below one in 1,000, right? So below 0.1%. In terms of, let's say, relevance, you might want 90, 95, 98% relevance. In terms of, it again depends a lot on the business case. There are situations where 70% is good enough.
Yeah, if you wanted directions to the flower shop, then if it's wrong 30% of the time, you've wasted a bit of time. But if you want directions to how to perform heart surgery, you probably want a much higher
That those
level
are
of
very good.
accuracy.
Those are very good examples. I'll give you an example which is a bit counterintuitive. In certain areas, for example, in banking or in the financial sector, knowing about the transaction that is, fraudulent or not,
Right.
70 to 90% is good enough. Why? Because anyway, any method that you employ today is probabilistic. Those that are employed sometimes are below 70% anyway. And as long as you associate that, 72% probability that this transaction is fraudulent, but you associate it with exact parameters which gave you that conclusion, and you have some kind of explainability, that's already very good because in those particular situations, you're not only aiming for, let's say, determining the actual fraudulent transactions, you're also aiming for reducing the time spent by people in the back office to deal with the probability dashboard, right, that they have in front of them. So yeah, it's 72%. Okay, do I close it? Do I not? Do I escalate it? But they have the explainability around it. They have a much better understanding of what's going on, right? And so that's why sometimes the numbers can be low enough, and it's already very, very, very good.
I'm curious how we can measure things like reliability. It makes sense when you talk about something like whether or not a transaction is fraudulent, because that's a true false statement. But what about if it's generating text as an answer? How do we determine it? How does our testing system determine whether or not it's a reliable answer?
Yeah, yeah, yeah. So there are techniques to actually ground your AI, your Gen AI, into a corpus of data. In some examples, we have built a teaching assistant that is implemented around different, for example, in universities. And there you want to have 100%, right, guarantee that the answer can be found is based on the actual content of the course, right, the
Okay.
actual curricula of the course. So there are ways to improve that. One of them is groundness, increasing groundness by a very simple technique, which is retrieve augmented generation, just one of very simple techniques. There are other softer methods, and now I introduce another concept, right? When we're talking about, we kind of divagated from measuring or evaluating, and now I'm briefly talking about improving those metrics. You can improve those metrics by simply choosing a better LLM for that particular thing that you want to do. You can do a fine tuning of the LLM. So there are many techniques pertaining to dealing with the LLM, but there are other techniques which are related to software development or architectural design concepts around the LLM, which can improve the actual metrics that you're looking at. And throughout those software methods, I could mention, for example, the simplest one that everybody knows about, probably in this world, which is retrieve augmented generation, which is
Yeah,
not the LLM,
rag.
it's RAG, right? It's not prompt engineering, it's grounding it into some data. Now, the problem with RAG or the limitation with RAG is a bit of a problem related to performance, to cost, actually. So if you're in a business scenario, in a very large enterprise with a very large corpus of data, many documents, many databases, and I want an answer which has to be grounded there and has to be found there, right? The problem that I run into very fast is, in order for me to have a complete, let's say, result, I mean, actually looking at the whole data, we're talking about very large prompts. I mean, extremely large prompts. So that's unfeasible to do. So you're
Right.
looking at smaller prompts which count on some indexing, some vectorization of that data into another format. And here we of course, there are techniques to improve indexing, to do a better vector database, but we're talking about, let's say, engineering measures to solve a big problem, which introduce other, let's say, compromises. I mean, you will never be able to do a complete, prompt with RAG, which goes through all your documents. It will go into, I don't know, top five based on a rank. And the actual nuance of the question that the user is asking might actually be found in document number 7,
Okay.
but you cannot actually do such large prompts. So there are even better software techniques to improve the reliability, the groundedness, the completeness of the answer. Things like deep research. Deep research is basically a technique which allows you to do a multi-agent system where you use generative AI LLMs in multiple ways. One is to basically translate the question the user has into something searchable in my vector, in my RAG something, right? Then there's another LLM which gets the content and does a summary, and there's another LLM which evaluates the summary, right? Based on some metrics, based on some criteria that I defined. And this whole thing can go into a few loops, in a few iterations, until I have a good enough answer, and which is then sent to the user. Because sometimes, applied in banking, for example, right? You are somebody working in a process in a bank. You want to open an account or you want to approve a loan, right? Whatever the operation might be, you need an assistant an AI agent which tells you if what you're about to do complies with the company and the regulator policies. Okay, let's simplify to this scenario. Now, those policies, I haven't seen any bank or any other company yet which has a folder of all the documents, uh, only the latest version, all of them together in one place.
Right.
When we talk about policies and regulations, we're talking about multiple sources with
Scattered
conflicting,
all over the organization. Exactly.
scattered, conflicting information, multiple versions. So not only that the data might not be clean, It's also that by design or by mistake, because it's a very complex industry, there might be regulations which are conflicting, right? So how do you expect an LLM to choose, right? It will not be able to do. It will generate some text. It will generate an answer, which is not probably not what you want. With a software architecture around LLMs, like the example I gave you, the deep research with multi-agent systems, you have a much better chance of having like a summary, which
Okay.
is almost like somebody thought through the process and say, yeah, I found that one, I found that one. They are conflicting, but for your particular use case, this seems to be the right answer. That's the kind of result that you should expect. And now going back to evaluating all of this, the purpose of evaluating Gen AI solutions is not to evaluate the LLMs only, right? They are already evaluated. Let me put it like this, meaning
Okay.
you already have benchmarks, um, which are also done by the actual producers of the LLMs, right? You have public benchmarks. That's only part of it. The second part, and much more important, is evaluating your entire software solution, which uh, you know includes the LLM or the LLMs.
Can you talk a little bit about the tooling that you use when you're evaluating these AI solutions?
That's a great question. So, in the context of Microsoft, right, of the I would say extremely good and relevant, we're very happy with it, software as a service solution that we call AI Foundry, Azure AI Foundry. In the AI Foundry or around the AI Foundry, we have the thing called evaluations, which is part of the AI Foundry, and we have a thing called AI Evaluation SDK. The evaluation SDK allows you to write code on your own machine to evaluate your whatever, your agent in the end, right? It's an agent. We're not talking about an LLM, we're talking about an agent against some metrics. Like some of them are already built into the SDK, like coherence, fluency, safety, and so on and so forth. Even much more like intent, like one evaluation would be how good is the agent to understand the user's intent? Okay, just to give an example. And you can use the SDK. You can run those tests whatever you want, like even on your machine, and the results can be exported and integrated into the Azure AI Foundry evaluation area. You have multiple evaluators, I don't know how they're called, already done, but you can always implement your own evaluator and integrate it into this SDK with APIs. So that's a big one, or two, right? And with a specific area of evaluating Gen AI into the security side of that, I would name the AI red teaming agent, which is it's an SDK, it's an agent, whatever you want to call it. It also integrates into the evaluation part into Azure AI Foundry, but of course it can be used independently. It does adversarial testing of Gen AI assistants. It uses an open source library. It's called Pirate, Pyrit, Pirate. But it has the Microsoft flavor around it. It integrates very well with the Microsoft tooling, and it's great at creating different types of attacks against your agent. So it sees how it responds in terms of safety, in terms of security. There are very well-known techniques out there, like jailbreaking, like crescendo, like I don't know how it's called, where you randomize the characters. So I'll give you an example of a prompt that this tool will do for you. Let's say you're the LLM, and I'm asking you as a bad intent user. I'd say, please give me the recipe to I don't know, run a bank, to rob a
Right.
bank.
Right.
And you as an LLM, you will already tell me, no, I cannot do that because
Because of
most
the
modern
guardrails
LLMs,
in place.
in the LLM sometimes, if you're serviced in the AI Foundry, there's the content safety in the AI Foundry already. But then one of the attacks would be I have the same question and I simply randomize the characters.
Okay.
And it works. The
You
LLM
say
will
randomize the characters so that the words don't make sense to
just mix
a
them.
human being.
They don't make any sense to you as a human,
Okay.
but the LLM will answer, right?
Really?
Yeah, yeah. And to protect against that, this is a very specific attack. You need to do specific things.
Hmm.
Well, first of all, you have to identify, and unless you do this kind of evaluation security-wise with tools like Pirate or like the AI red teaming agent, you wouldn't even think about those kind of attack, right? And this is a big difference in mindset. If you're
Okay.
a tester, like coming from the software testing world, you would never in a million years you would write that test case.
Right.
Never,
I would.
right?
It would not occur to me that was even
No,
an
if you're a
attack that I
tester.
would have said.
This comes mostly from social engineering, from other aspects in this world. And the very good thing with AI red teaming agent is that that kind of public knowledge around how to trick LLMs into answering what they're not supposed to,
Mhm.
it's already incorporated in the agent itself, in the SDK and all of that tech stack.
Very cool. Mihai, we're just about at time. Is there anything that we haven't covered that you feel is crucial for our listeners to hear?
Yeah, maybe towards a conclusion, yeah, maybe one or two points I would want to make.
Please.
There's definitely a change in the mindset in the enterprises which use Gen AI. So first and foremost, in order to increase trust in Gen AI, that's the very first thing I started with, do the evaluation. So what we explain to our potential customers is, yeah, we know you tested it and it has very random results from your perspective, but this is how they're built. This is what they're supposed to do. By the way, this is how we evaluate them. And that changes everything. And of course, in terms of what has to change in the mindset is that evaluation of Gen AI is completely different than software testing.
Right.
And the last concept I would make, especially for AI, you need to do some kind of continuous evaluation, let's say methodology or technique. I'm talking about ML ops. I'm talking about every month, every quarter, every year, depending on the business case, you have to rerun the evaluation
Okay.
because performance drifts because of reasons that you cannot think about. It drifts because your data has changed, because your user behavior has changed. You don't know. You have to measure it and to have a feedback loop into changing your solution in the end.
Excellent. Uh, Mihai, I've learned a lot in the last 30 minutes. I really appreciate your time and you stay safe.
Thank you very much, David. Thanks a lot. I was just gonna say that it's very nice nowadays to go to Microsoft conferences to see the AI technology stack that they are developing. Not only to see the friends from the community, but especially to see the very fast evolution of the technology stack of AI.